Momentum and rotation review 10. An object rotates according to that equation right there. At t equals 1 second, determine the object's angular velocity and angular acceleration. Angular velocity, we recall, is the time derivative of the angular position. So let's differentiate this. When we differentiate polynomials, we power down. So that's going to be 9t squared plus 8t plus 5. If we put t equals 1 in there, that's going to give us 9, that's going to be 8, and of course that's going to be 5, so that's going to be 22. 22, and what's the proper unit for angular velocity? Radians per second. 22 radians per second. What about angular acceleration? Angular acceleration is the time derivative of the angular velocity. So now we need to differentiate this. Power down again. I'm seeing 18t plus 8. Put t equals 1 in there, and that's going to be 26, isn't it? 26 radians per second squared. Letter O. If the part N object is a uniform cylinder rotating about its central axis, there's its mass, there's its radius, find the net torque acting on the cylinder at t equals 1 second. All right, so let's see. Net torque. How do we do this? Net torque. What's net torque? Net torque, according to Newton's second law for rotation, is I times alpha. We know what alpha is for 1 second. It's 26. And we're looking for net torque. What about the moment of inertia? Well, the moment of inertia, this is a cylinder, so the moment of inertia is 1/2 mr squared, and then we want to multiply that by alpha. M is 2, r is 1, alpha is 26. Are we able to do this in our head? 26. What's the unit for torque? Newton meters. Remember, don't ever change the Newton meters of torque into joules. Cannot do that. Leave it as Newton meters. How about the rotational kinetic energy of the cylinder at that time? Well, let's see. What's the rotational kinetic energy? It's 1/2 I omega squared. And we figured out the moment of inertia. What's the moment of inertia? Right here. 1/2 times 2 times 1 squared. So the moment of inertia has a magnitude of 1 for the problem we're doing. And then omega squared, what was omega at time 1 second? Way up at the top of the screen on the left, 22. Square that. 22 squared is 484 divided by 2 is 242. 242 joules. Kinetic energy is in joules. Last one. How about the angular momentum of the cylinder? Well, let's see. What's an equation for angular momentum? It's moment of inertia times omega. I know that. And the moment of inertia is 1. And at 1 second, we figured, there it is again at the top of the screen, at 1 second, omega was 22. So down here at the bottom of the page now, the moment of inertia was 1. Omega at that instant was 22. So that's going to be 22. Now, one more time. What's the unit for angular momentum? This one's a little tougher to remember, but you can always use the equation to help you figure it out. The moment of inertia always has the unit kilogram meters squared, and the unit for omega is radians per second. And remember that a radian is really a nothing unit. It's just something that we say because we don't feel comfortable not saying anything. Kilogram meters squared per second.